Good day. This is Module 2. I will present to you additional solving problems involving vectors in the plane. So we have the first example here. Find the components of the vector P1, P2, given P1, whose coordinates are 4, 1, negative 3, and P2, whose coordinates are 9, 1, negative 3. So in solving that problem, we have the vector P1, P2 to be defined, where we have here the coordinates of your 2 points given. So based from the formula that we have learned, it is the difference between the coordinates of your 2 points starting from the terminal point minus the initial point. So we have 9 minus 4. That's the first component of your vector P1, P2. Then 1 minus 1. Then negative 3 minus negative 3, that's negative 3 plus 3. So simplifying it, we have it as 5, 0, 0. So we have here the components of your vector P1, P2 in bracket notation. If we are asked to find the IJK notation of this given vector, this will just be 5i. So it is expressed in terms of linear combination of the standard unit vectors IJK. For the second example, we have here, find the initial point of vector V whose components are negative 3, 1, 2, if the terminal point is 5, 0, negative 1. So to illustrate, so suppose this is your vector V whose components we have it as negative 3, 1, 2. Then we have the terminal point, let us call this as point B. So we have it as 5, 0, negative 1 as the coordinates. And let us have this as point A as the initial point, whose coordinates we have it as x1, y1, z1, and it is to be found. So with that, we can have the formula last time. So the formula is we have v equals x2 minus x1. That's actually v sub 1, okay? So v sub 1 is referring to negative 3, x sub 2 is referring to 5, so we can get x1. So we can substitute. This is negative 3 equals x2 is 5 minus x1. So transposing x1 on the other side to make it positive, then this will be 5 plus 3. Also transposing negative 3, that becomes positive 10. So x1 is equal to 8. When we are to find the y1, you can use the formula of v2 equals, you have it as y2 minus y1. So v2 is equal to 1, y2 is equal to 0 minus y1. So therefore, y1 equals negative 1. Then to find z1 is the third component. So we use the formula v3 equals z2 minus z1. And v3 equals 2 equals z2 is negative 1. Then you have minus z1. Transposing now negative z1, this will be positive z1 equals negative 1 minus 2. That's equal to negative 3. Therefore, the initial point, we have it as x1 is 8, y1 is negative 1, and z1 equals negative 3. We can do the checking and how it is. So vector v equals your line segment vector A, B. So we have this vector v as negative 3, 1, 2. So let's get the components of AB now using, you have the defined answer for A, that's 8, negative 1, negative 3. So let's subtract now. 5 minus 8, that will be negative 3. Then 0 minus minus 1, that's positive 1. Then negative 1 minus minus 3, that's negative 1 plus 3, that's positive 2. So we have the same components rather. So that means our answer is correct. We have here another set of problems involving vector operations. Okay, let's have the first problem here. Find the norms of v equals negative 2, 3, then v equals negative 20, 30, and w equals 2, 3, 6. So when we talk about norms, it refers to as length or magnitude. So with that, we can have this as, for vector v, the norm of vector v would now be equal to, so we use the symbol, magnitude of v or norm of v is equal to the square root of quantity negative 2 squared plus quantity 3 squared. So the answer is 4 plus 9 is equal to 13 squared of 13. For 10v, the magnitude or norm of 10v is equal to the square root of negative 20 squared plus 30 squared. So we know that negative 20 squared is equal to 400 plus 30 squared is 900. So therefore, it is equal to square root of 1,300. Then for the magnitude of W, so we have it as square root of quantity 2 squared plus quantity 3 squared plus quantity 6 squared. So this is 36 plus 440 plus 9, that is square root of 49, or this is also 7. Then to solve for number 2, find the unit vector that has the same direction as v equals 2i plus 2j minus k. So let's recall the formula of unit vector. It is equal to v over magnitude of v. So let's find the components of your v in bracket form. Do we have it as 2, 2, negative 1? That's your vector v. Then finding its magnitude, so we have this as square root of quantity 2 squared plus quantity 2 squared plus negative 1 squared. So with that, magnitude of v is equal to, we have this 4 plus 4 is 8 plus 1, 9. Square root of 9 is equal to 3. So with that, the unit vector is equal to v, where it has 2, 2, negative 1, all over 3. You can also write this as 2/3, 2/3, negative 1/3. You can also write in IJK format. So we have here 2/3 I plus 2/3 J minus 1/3 K.